Hello everybody, I am Ben from Team Panic, and today we're going to be looking at and doing a tutorial for what I believe is the easiest combat robot spinner in any weight class. That is this guy, Guestimate, my 150 gram ant weight horizontal spinner. Now in its current configuration, it is definitely just a easy way to get somebody into the arena. There are lots of things about this that can be upgraded and changed, and we'll talk about those at the end of the video. However, the upgrades and changes are something that can be done post first or second event, whatever the person wants to do. The whole idea of this is to get somebody into the arena with a spinning weapon quickly and easily. To do that, we're going to have to sacrifice some things, and one of those things is how heavy and how hard we actually manage to hit with this combat robot. So let's just jump straight into what you need. Okay, so we're going to start with the tools that you need. And the first tool we're going to look at is not even one that's on this table. It is a 3D printer capable of printing both PLA and ABS plastics. Now, don't worry if you don't have a 3D printer of your own. Look for local makerspaces, hackerspaces, fab labs, libraries, and community centers. These days, those type of places have printers, or some of them have, or a lot of them have printers that you can use cheaply or for free, depending on the place. So check those places out first. If none of those things exist by you, then try a printing on demand service, such as Shapeways, or 3D Hubs is another one where you can get in contact with people who have printers and get them to print you things. So if you don't have a printer, that's the way to do this. If you do have a printer, just print your own parts. Then we're going to look at the other kind of power tools here, because there's only two that are actually wall-powered tools, and that is the soldering iron at the back here, and because you cannot get away from soldering when you're doing combat robots. So I would also recommend, before you do any soldering on a combat robot, do some small-scale soldering projects first. Look for some soldering tutorials on YouTube, that type of thing, and do some soldering before you do a combat robot. Because a combat robot, even though this one is the simplest spinner that you're ever going to build, there is still a little bit of soldering that you need to get done and get right. Then we also have a hot glue gun. This is a pretty industrial-sized hot glue gun, but you can use a small hot glue gun. It doesn't matter as long as it heats up and it heats up glue. Also, go for medium to high temp ones. Don't go for low temp glue guns because they're just not worth the time and effort. Then down here we have pliers and side cutters. The side cutters are going to be really helpful for all of your wiring and your soldering and dealing with all of your wires, cutting them down, stripping them, and getting them ready for soldering. The pliers we're going to use in a bunch of different places throughout this build, and they also have a nice little cutter inside them, which we're going to use to cut some wire down. Then we've got screwdrivers. Realistically, you only need this guy. This is a little jeweler's screwdriver, but having a slightly larger screwdriver with a nice handle on it so you can get some good torque on the screws going in is probably a good thing as well. Pair of scissors to cut things down, and then also a tiny little Allen key set. Building anything at the ant weight scale, you're going to need Allen keys like this, because a whole bunch of the motors and things that come in kits and bits and pieces that you'll find use very, very small Allen head screws to put them all together. And we're just going to use the screws that come with the motors, so we're not doing anything too fancy with that. So get yourself a very small set of Allen keys. Quick addendum to the tools, you also need one of these, a FlySky transmitter. Now this is the FSI-6, which is what I personally use. It's a kind of mid to low range transmitter in terms of cost, and it's really good because the screen here allows you to program all of your mixing and things on the actual transmitter, so you don't need to connect it to a computer, and you have more control over it than some of the lower end transmitters that just have switches that allow you to do some very basic mixing. So this is my pick for the FlySky transmitter, but like I said, you do need a FlySky transmitter of some form. And that's it for the tools. Let's move on to the materials. So here is all of the major components for this build. There will be a link or a list of links in the description. Those links are going to be for searches for these type of things on like AliExpress and Banggood and places like that. I'm not going to give exact listings because listings will shift and change, but if you take the search terms, you can then find all of the things that I have. I'm going to speed through these pretty quickly, other than a few key components that we're going to talk about in a little bit more detail, because some of the components in here are the reason that I say this is one of the easiest spinner builds that you are ever going to come across. So we're going to start over in the hardware side. So one of the things that is a complete game changer here is this carbon fiber drone arm. This is what your brushless motor mounts to, that has the weapon on it. This thing is light, flexible, well, light and strong. It's got a little bit of flex to it, but not a lot. But this is the easiest way of mounting a weapon up in a reliable fashion. Also, when you do your search for these, get the ones with the star-shaped pattern in the head of them, because this star shape is designed to accept multiple different types of brushless motors. And even though I'm going to recommend a brushless motor in a second here, you want this type because in the future you can change your brushless motor over to get more torque or get more speed, and a star-shaped cutout like this is going to allow you to fit more types of brushless motor to your robot. So that's the type that you want. And like I said, I will leave a search to the exact name and stuff of these carbon fiber drone arms in the description. We're also going to need some small self-tapping screws, some M5 nuts. These are going to be either lock nuts or normal nuts. Then you're also going to need some short countersink M5 bolts. These are going to be the head of our weapon, so they're very important that they are countersink ones. Some M3 bolts, these are really short ones. Some Pololu wheels, these are 40mm Pololu wheels. I'm going to give the link to the Pololu store here because these things are relatively cheap, and it's better to get the Pololu ones than the cheap ones from AliExpress or wherever, because they can go wrong. You need a battery connector like this one. These normally come in big packs. You need a switch or a power link or a screw switch of some sort. Now, this I'm not going to give you too much information on, because here in Australia, this type of mechanical switch is totally fine to run in an ant weight. However, your local league may have differing rules on this. In the UK, for example, you can't use switches, so you have to use a power link instead. But you do need some form of power isolator, which is what this is. Check out with your local event or the event that you want to go to, check their rules before deciding on a switch of any kind. You want one of these guys, which is a 180 milliamp hour 2S battery. This one I got from Hobby King. I don't believe these are available anymore, so I will find another source of these and put a link in the description. We're also going to take just any old type of thin plastic. This here is out of a juice bottle, so raid your recycling bin and you'll find some plastic which will work. This is literally just for a top cover, so it's just to hold some electronics in the robot. Unless you're facing an overhead saw of some kind, this is going to be perfectly fine for what we need. Then we get to the actual weapon system. So this here is a 12 amp ESC, brushless ESC. Brushless ESCs have 3 wires. You need to make sure you get the 3-wire version. And this 12 amp one is actually slightly bigger and it's a little bit less expensive than the 20 amp ones that you can find around the place. So if you're worried about weight, you can get 20 amp ones, which is smaller than these, which work just as well. And I will, like I said, leave links to these type of things below. For motors, I recommend these. These are 1806 brushless motors, and once again, there'll be links to a search term down below. You want the counterclockwise ones, because counterclockwise is, well, in most cases, counterclockwise means that the actual motor spins counterclockwise, and that means that the screw thread on it is a clockwise thread, which means that you can put a conventional M5 nut on it, and that's the type of thing that you want. If the listing talks about the thread, you want a clockwise thread. If it doesn't talk about the thread and just says counterclockwise or clockwise, go for the counterclockwise ones so that you get a clockwise thread, just like that. Then onto the main body of the electronics. We have the FlySky receiver that I talked about in a previous video. These things are amazing. They can take 2S voltage, no problem, which means we don't need any regulator or anything like that connected into the board. And they're relatively cheap and they're really, really lightweight, which is great. I will leave a link directly to these in the description. And then Finally, we have, in terms of the electronics anyway, we have these DF robot motors. Now, the actual motor itself is commonly called an N20 gear motor. You can find these on AliExpress and Banggood and all that kind of stuff. They are a good motor for this weight class. They're basically the only decent choice for this weight class. And these DF robot ones have a motor driver on the back of them. So you don't need a separate ESC. Everything is done on this board. And that literally means that you wire these things directly into your into your receiver, and they just work. Especially with this guy, because you're running 2S straight into there, and then you're running the power from that straight into here, and it just goes. So I've been using these in my combat robot spinners for a while now, including my big heavy hitting spinners, and they work really, really well. I contacted DF Robot about them and about this video, and they sent me 2 as review units. So here is my review. These things are awesome. Definitely use them in your Antweight combat robots. They are just lighter and easier than any other combination of N20 and ESC that you will get out there in the wild. They do have a slight limitation, which seems to be that they don't push the full 2S voltage through your actual motor, but on the whole, that doesn't matter. We're making a spinner here. We don't really care all that much about pushing power or speed of the robot. These are a 50-to-1 gearbox. You can get a 30-to-1 gearbox if you want to go that little bit faster. Personally, I prefer the 50-to-1s, especially for a beginner. They are a lot easier to control than a 30-to-1, and you'll keep up with most of the other robots that are out there in the field. And at the same time, it doesn't really matter because you have a big spinning weapon, or you will have a big spinning weapon after you've finished this tutorial. So even if you can't keep up, you can at least turn on the spot fast enough to put your weapon where it needs to be. So that's those guys. And like I said, those 2 things together with the carbon fiber drone arm make this the simplest combat robot spinner build that you can do. Then we've got some glues and adhesives over here. So I've just got some Velcro. This is more industrial strength stuff from a hardware store, but any old Velcro will do. Super glue, get the cheapest super glue you can find. This stuff sticks really, really well, especially for a lot of different bits and pieces that we're going to be doing. Super glue, especially the cheap stuff, is a good one. Hot glue sticks, these are for a hot glue gun. You should always have hot glue when you go to a combat robot event, and we'll be using it a little bit in some of the construction of this. And then a 2-part epoxy. This one is in a syringe so that it evenly measures out as you push the stuff down, which is really nice and handy, but it comes in many different forms. Just get any kind of 2-part epoxy. Usually 5-minute stuff is good enough for the combat robot stuff that we are doing. And then the last thing here is an optional one. This is a loop of wire. This is just, I think, fencing wire. Once again, I got this at a local hardware store. It's pretty thin stuff, but it is good enough to use as a standoff underneath the robot. Now, like I said, this is optional. This is basically an optional way of making sure the robot drives okay upside down. If you don't use this stuff, then the robot drives on top of the brushless motor spindle as the motor is spinning around, which is going to mean it's going to interfere with your turning ability. And the way to fix that is a loop of this type of wire, but we'll get onto that later when we do the build. Okay, so that is now all of the components and materials you need. Also, you do need 3D printing plastic to go with the 3D printer. But that's it, that's all you need. So let's get started by looking at the 3D printing. For the 3D printing, you need to download the 3 files available on Thingiverse. Those are the body, the weapon, and the motor mounts, and you need to print those. Now, the body and the motor mounts can be printed on very similar printing settings, and they can be printed in ABS or PLA. ABS is going to be stronger and also lighter, which will give you more weight to modify the design if you want to. However, it is a harder thing to print, and a body that size is a harder thing to print. So if your printer is not set up to print ABS well, then I would suggest printing these in PLA because it will be easier and faster for you. Now, the other settings that you need to know, I print all of mine in 0.2mm layer heights, and then 3 to 4 walls and kind of 2 to 3 top and bottom layers, and about 20% infill for the pair of these files. Obviously you need one body and 2 motor mounts. Moving on to the weapon, this one needs to be printed in ABS because it needs to be strong, and to keep it strong we're going to do our print settings very, very high. So we're going to print at somewhere in the order of 16 to 20 walls, and we're going to use a 10 to 15 top and bottom layers. This is going to increase the strength of the part. Having more walls is better than having higher infill. Having said that though, we are still going to be using a 90% infill for just the small pieces that we need. We also do need to print this one with supports. So now that the parts are off the printer, it is time to actually get all of this together. And I need a screwdriver as well. So coming off the printer, these will have some support material in underneath the bottom down here, and also in the holes at the either end of the weapon bar. My weapon bar didn't print very well. I think I need to change my print settings a little bit, but yours should come out a lot better than this. And then once you've got them out and removed your support materials and whatever raft or brim you've used on the ABS part, it's time to glue these together. The only other thing is if you've got a thin enough screwdriver, I just suggest giving a little quick poke through these holes, just so that we know that there is a good space for the screws and bolts that we're going to put through here in a second. And you only need to do the front two. These back two are optional, and realistically, if you put them in there, it's a little bit harder to get the battery in than anything else. So just do the front two and you'll be all good. Okay, so those two are prepped. The screws are fine. We don't need to do anything with those, although it does help to screw in your bolts into your weapon bar first before you attempt to do this with glue on it. So screw these all the way down into the plastic, because this will tap threads into the plastic, and then when we add glue, the glue will stick inside those threads and everything will get bound up and it will work nice and tight. I've already done that on this guy on both sides, so we don't need to do that right now on camera. So that's all good. And then the final thing is these carbon fiber drone arms, they have a nice lacquered, smooth finish on the front of them. Glue is not going to stick to that very well, so we need to rough up this surface here from about here back. Basically enough that it's going to sit inside our chassis, just like that. Just in there, in actual fact. So yeah, you can see we can kind of go from about here on the piece back, and we need to find out or work out which way around we're going to put this in, and I think it's going to go in this way around. So we need to pull this back out, or maybe it's going in that way around. I think it's going in, yeah, going in that way around. So it's going in this way around. We're going to find our mark, kind of somewhere down here, and we're going to rough up all of this. Now we're running on limited tools. If you have a file handy, just hit this with a rough file and that will do the job. If you don't have a file handy, we're going to use our pliers, and the way to do this is to dig the corner of the pliers into the material and scrape, and you'll end up making nice lines across the surface here. Now I'm not exactly sure if you can even see this on camera. Maybe if I get the light on it just right, you'll be able to see these scratch marks. But basically, I'm just digging the corner of the pliers into the material and scratching it on up. And it really doesn't matter how you do this. You're basically just getting a good surface for the glue to bind to. So the scratchier you do this, the better, basically. The more marks and the deeper they go, the better for this, because it will give more surface area for the glue to stick to, and you'll get down into some of the carbon fiber layer, which will give you a better bond overall. So yeah, the more you can sit here with the corner of your pliers and dig in, the better off you'll be. Now these marks down here might just show up on camera maybe. Yeah, there you go. If I sit them that way, you can see these marks down here. So those are nice deep ones, which is going to be good for the glue to stick into. Yeah, so like I said, just mark this up basically any which way you like. Doesn't really matter too much. And then once that's all marked up, it is time for glue. So with your epoxy, you want an equal amount of parts A and part B. I have this nice little syringe set up, so it's pretty easy to do that. And you're only going to need a little bit of this. You don't need a whole lot. If we get some epoxy out. And about that much. I'm just kind of eyeballing this. If there's a little bit left over, it's not going to matter too much. I'm just going to draw that back in and put the lid back on. But yeah, so you get an equal amount of part A and part B. I have a little epoxy stick that I use for a lot of things that came with some epoxy at one point. If you don't have this, grab a pop stick or another piece of cardboard or anything you like, really. It doesn't really matter all that much. Then we're going to mix this up and we are going to slather it onto the piece that we just marked up. Nice and thick. Don't really worry about the holes too much. We're going to put bolts through the holes with this glue still wet. Basically, these bolts are never coming back out of here again, which is fine because we bought them for this purpose, so we don't need them back. If you do think you need them back or want them back or whatever, yeah, buy other bolts for this purpose, because once these things go in, you're never getting them back out again. And now I've done the back, this side that we scratched up, and I've also done all of the edges as well, because your carbon fiber arm should sit in, and you can see I've got a little bit of glue oozing around the edges. That is a good thing. That is kind of what we wanted to see. Now, I've done this poorly because I should have had the nut off the end of both of these bolts before I started this process, but that's okay. I've got a little bit of work time, and that is part of the reason we're using epoxy. A, it makes a very strong bond, and B, well, it gives us time to work and to get everything done. So I'm just going to push this bolt on in here. If it doesn't go immediately, you might need to give it a quick screw to get it through. That might just mean that there is a little bit of plastic in your print that didn't go quite right, and it's sticking out a little bit. So we're just going to screw that on in here like this. And I'm going to put the nut on the back and tighten it down as much as it will go, because we want this to be really tight, because these are basically going to act as the clamps to hold everything in place as our epoxy sets up and cures, because that is going to take some time. So these epoxies do have on them how much their work time is. A lot of them have a 5-minute cure time, and then they also recommend standing for another additional 12 hours to get a full cure. So it's good to, especially if you're going to put this thing into combat, giving it that full cure time and letting it sit and rest. Like I said, it will set up and it will be manipulatable, or it will be stuck and seem really stuck. You'll be able to hold the whole robot by the carbon fiber arm in about 5 minutes, but you really don't want to put it into full combat until after that time. Now, these bolts are a little bit long, and I will have the correct bolt measurements in the description so that you guys can get the right size ones and not the ones that I have, which are just a little bit too long. They sit a little bit proud. But once those bolts are in, we're then going to tighten those up. And I'm using regular nuts here, and when we get to the build stage later, we're actually going to add a little bit of super glue to those, hot glue to those, for two reasons. One, to lock them into place, and one, to electrically protect them so that they don't contact anything else and short anything in our electrical system, which we'll talk about while this glue is drying up. So now that that is in, that is clamping our carbon fiber drone arm into place. We're just going to sit this down so that where it sits, the glue, that's sitting in the glue that we just did up. We don't want to do that. Sit this over on the corner here, just like that. So all of our glue is kind of on our cardboard here. And then the final step is, as I said before, we are going to glue onto our screws over here. So this is typically easiest with the screw on the edge here. Then just coat the tip of the screw in epoxy, just like this. Get as much epoxy on there as you can and try not to have it fall off. You really don't want to have a lot of epoxy on your skin. If you do get some epoxy on your skin, go and wash it off immediately. I've been very careful. I've got a little bit on me, but I will go and wash that off as soon as I turn this camera off. And then once you've got the epoxy in the threads, you want to screw the screw down into the weapon. Now the key thing here is that when you screw the two screws down, they should hit a stopping point where the head hits the plastic, and you want to make sure that where they stop is the same on both screws. Like I said, you've got a little bit of work time, so if this screw on the other side doesn't go in quite as far, you want to back this one out before the epoxy sets up so that the whole thing gets balanced, because it's going to be very important that you have balance across your two screws so that the weapon does not vibrate as it's trying to spin around. This weapon is pretty balanced as it currently stands, and yeah, you shouldn't have too many difficulties getting these screws in a close enough place to each other for the weapon to not vibrate all over the place. But yeah, just make sure there's not miles and miles of difference between the two of them. And like I said, then we will epoxy this guy in here, just thread that all the way down. And once we've done that, it is now time to leave this epoxy for 12 hours. So while that is happening, we are going to go and work on the electronic system. That's definitely not going to take us all 12 hours that it's going to take for this stuff to set up, but it's something that we can do in the meantime. So let's take a look at that. So while the glue dries, we are going to look at the wiring for this whole thing. So on the board in front of me, I have all of the things that you need and all of their wiring connections. Right now, we're only going to talk about the connections. I'm not going to do a whole soldering tutorial. There are plenty of soldering tutorials out there on YouTube. So if you haven't ever done any soldering before, I would suggest looking some of those up and maybe even doing a small soldering kit before attempting some of this stuff. This isn't the hardest soldering in the world, but it would be good to try some soldering out before attempting to do a robot as your first set of soldering. But having said all of that, so this is our setup. Up the top here, we have our power setup. Then we have our receiver in the middle, we have our drive, and then we have our weapon down here. So let's start with the power. So as I said at the start, we've got a battery connector here, which will then connect off into our battery, which I haven't drawn because it's literally just a plug connection. You don't really need to worry about wiring for that. We've got some form of power isolator. In my case, it is a slide switch, like I said before. Make sure that whatever you put here is allowed in the rules of the competition that you want. And also an LED. This is an optional thing, and once again, it comes down to what your group allows, because the radio receiver that we're using does actually have an LED on it, and it will turn on and stay on when it is connected to your radio. So some events will allow this as your power light, other events will not, and you will need a dedicated LED. But we'll talk about how to wire this guy up as we go through. So first of all, we're going to talk about how we're going to connect everything out to the receiver. So the receiver, you'll see, has 4 channels, and each channel has 3 dots. So these dots are for different things. The middle row is always power on all of these, just like this, because power is always in the middle of the 3 connectors that are on a servo, which is what normally hooks up to a receiver like this. And then as a good rule of thumb, the closest pin or the closest hole to the chip that sits on the receiver, on any receiver, is going to be your signal that goes in. Now, this isn't always the case, but it is on 99% of receivers that you will ever find. So that means that our signal goes into the top here, and the last thing we're left with then is the negative or the ground going into the bottom. So that just leaves how we hook this receiver up to all of our stuff. So we're going to start with the drive over here. So these are the 2 DF Robot N20 gear motors that have the ESC in them. So they just have, well, they have 3 wires off the back of them, and those need to get connected into your receiver. So these are going to be connected into channels 1 and 2, which we're going to set up, or you'll need to set up on your controller as the drive channels. So the green line here is going straight into the signal port, because the green line there is the signal. The red line is the power line, so that we're going to put straight into the power in here. And then the black line is, of course, ground, as it normally is in anything electrical. So that's going to get connected into the ground, just like that. And then the same with the other motor. So the other motor is going to go, once again, green is going to be our signal, so that's going to go up in here. Red is our power, so it's going to go up in here. And then black is our ground. It gets connected across to here, just like that. Next, we're going to look at the ESC. So the ESC, once again, is going to have 3 wires. One of them is going to be a black signal wire or a black ground wire or a brown ground wire, depending on the type of wires on your ESC. It'll either be black or brown. And then the wire that I've got in blue here is the signal wire, which is either going to be white or yellow, depending on the ESC that you get. So it's going to have 3 inputs from your receiver. It's going to have 3 outputs that go towards the motor, and it's going to have a power and ground line. Now, when we're hooking up our ESC, so the first thing we want to do is we're going to hook this into channel 3. So we're going to hook up the signal line first. So that is the white or yellow line. We're not going to hook up the red line in here. This line is not going to go anywhere. That's because this red line, if it exists, which it may not on some ESCs that you can buy, this is a 5-volt line coming off of this ESC, but we don't want 5 volts on this receiver. As I said before, this receiver can handle the full 2S voltage, so we want the full 2S voltage on this board. So we're going to leave this one disconnected if that wire exists at all. If it doesn't exist, you're perfectly fine. If it does exist, just cut it and maybe wrap some tape around the end of it so that it doesn't short anything, but don't connect it to anything. And then finally, we have the black wire, which is going into the ground on channel 3, just like that. So now our ESC is connected through our signal coming in from our receiver. Our drive is connected to signal and power coming in through from our receiver. Then, as some of you have probably realized, there are 3 output wires off of the ESC and 3 input wires to the motor. So these literally just connect just like that. So now we've got all of our signaling done and all of our connection between our motors and all our ESCs. The DF Robot stuff makes this really easy because there's no connection between the ESC and the motor. That is already done for you when you buy the module, so that's really, really good. Next, what we need to do is set up our power lines. So our power lines come from our battery, and the red is the positive wire, so that is going to go straight into the switch, and then from the switch, it's going to go out, and it's going to attach to the positive rail on our receiver, just like this. Then the black wire, because we've already got this lockout on the battery, so this is where the battery power is coming in, we can just connect the ground wire straight in to the ground on the receiver, just like that. Now, because we've got lockout on one side, we don't need the switch on the other side as well. Electricity has to have a complete circuit to flow, so by eliminating or by turning the switch off, it cuts this line in the circuit, meaning that the circuit isn't fully connected and there's no power going around. So you don't need to worry about a switch on the ground wire. This is basically everything. All we now need to do is hook up the power to our ESC. So there are 2 ways to do this. One is to connect the power and ground lines to the same power and ground pins on the receiver. This is totally fine to do. So we can do this. And basically we're just going to piggyback these connections off of each other. Or if you're uncomfortable with doing that, you can avoid all of that and literally just splice the wire, which means that you create a little wire joint like this and you splice the wire together. Either of these will be fine to do to connect everything together. But as long as the black from the ESC eventually connects either back to this port or connects to the pin, the black wire coming off of the battery connector, and the red from the ESC either connects to this point or it connects through the switch into the battery connector once again. So you can also connect these into any of the positive or negative. So the red you can connect to any of the positive, and the black you can connect into any of the negative. Basically just what you've got spare and what you feel comfortable soldering things into. So there you go. That is the main wiring. That is the wiring setup as I currently use it in 2 of my combat robots. The final thing over here is this LED. This LED module I will leave a link to in the optional section down below. And it is a tiny little board with a very bright LED on it that has a positive and a negative terminal, which are marked with a plus and a minus. And to wire this into your combat robot, all you need to do is connect the minus to the ground and then the positive to the piece that comes off of the switch. Once again, you can solder these directly into the RX, the receiver module, or you can connect them to the wire at some other point. So now that you've seen how all of these connections go together, I will show you one that I prepared earlier. This thing does look like a little bit of a mess, but if we follow this round, you'll see that this does exactly the same as what I've just showed you. So under this silver tape here is my switch. As I said, this is a little slide switch. So we go from our battery connector, we run a red wire into the switch, then the red wire comes down here where you can see it is connected to 2 different things. So we've done this version where we've done one connection down to the ESC and the other connection has gone over here and connected into the RX, just like this. And then on the black side off here, once again, we've done a little split connection just there. Hopefully you guys can see that well enough. There's our little split connection. So that's this. It's come all the way down to this point here in the diagram. It's gone down to the ESC and it's gone across to the RX module. And then we have our 2 drive motors, which once again just get soldered directly into 1 and 2. Now you can see on here I've covered everything that was electrical either in heat shrink or in hot glue. For you guys, I would recommend the hot glue. Literally just get your hot glue gun hot, and anything that looks kind of silver, especially anything that you have been soldering yourself, cover the back side where you've been soldering and cover the front side, because this means that you're not going to get anything shorting across here, and it also gives a bit of strain relief on these wires. Basically, as the motor jiggles around, it's not going to bend the wires out of shape, it's going to kind of lock in against this hot glue and just help it survive a little bit better. Now, of course, the only thing that's missing from this is the actual brushless motor, which would just solder into these 3 here, but this has actually come out of my version of Guesstimate, and in its last fight, the motor came off the end of these because I did not Loctite the thing in place when I was using it. So we'll talk about Loctiting that in place when we get to the hardware, once, of course, the glue is dry. So let's go and see what we need to do once that glue is dry. Okay, so it is time for the final assembly. The glue has dried, we've done our electronics, they're over here in this little stack, and we have our hot glue gun going. So the very first thing I'm going to do is, as I mentioned before, just add a little bit of hot glue around these screws that are inside here. Just A, to keep them electrically insulated, and B, to stop them from backing out. They have been essentially epoxied in place, so they shouldn't really back out, but the nuts might work their way off and float around inside or something. So a double hot glue in there is a good start for this project, and just to kind of keep everything a little bit neater. Now, once we're a little bit happy that those have cooled off, then it is time to start working on getting the electronics in. So the first thing to do with that is you would need to get rid of your support material in under here. With a screwdriver, that's fairly easy to do. Just pop out a couple. Now, there are 4 holes in here. You don't need 4 screws per side. I usually personally only use 2 per side, and the 2 that I use are completely dependent on the day. But you do need 1 front and 1 back like this. You can't get away with it going both front or both back, because what will happen is your motor will kind of wobble in your motor mount. So you want 1 front and 1 back, but as long as you've got 1 of both of those, you're pretty okay. So to get this all started, we're going to get our motors. Now, both of my motors have been wired up and run in robots for a little while, so I know which one is left and right. You might have to put them in and then change the plugs over, because these plugs are still there, so you can unclip these and plug them into the other one if you somehow, if you accidentally get your left and right back to front. So at the moment, don't really worry about it. Just jam a motor into each of the motor mounts, just like this, and then set the motor mount for one of them down into its little housing, and it should sit in an exact spot, because there are some grooves in this 3D print that the motor mount should sit into. So if you're sitting a little bit far out like this, you aren't in the right spot and you need to push back to get the motor in the right spot. When everything's lined up, you should be able to see through the screw hole all the way through out to the table, because there are holes all the way through these motor mounts. So you should be able to see all the way through it. And when you can, you literally just put a screw in and screw that down. Now, the first time you do this, it might be a little bit difficult because the screw might want to go in a different direction, but just apply a little bit of force to it and it will eventually screw on in there. And I see, as I said, this one has kind of gone out a little bit sideways, so that's not a good thing. We'll take that guy out of there and we'll try a different screw, probably this one. It can be a good idea to go in with your screwdriver and clean these up a little bit. Just spin kind of in the middle somewhere so that it clears the hole out, because of course 3D printing will leave a little bit of material in there that the screw might get caught up on. Anyway though, get these screws in, and once you've got one side in, literally by putting in the 2 screws, you can do 4 if you want to, but like I said, it's not 100% necessary. Once you've got the one side in, I'm going to move over to the other side. I'll put the other screw in that in a second after I've finished talking here. And then, so that has lined up perfectly. We're going to get our other screw, which has gone over here. So we'll put that guy in here. Once again, try and wiggle it around and make sure it lines up with our motor mount. And then we'll put another screw in there. So then that's our 4 screws for our motors, and our motors are now locked in. Obviously mine aren't. I still need to go through and put another screw in each of those, but we're getting pretty close. Then we're going to plug our battery in. First things first, though, we need to make sure that our switch is in the off position, which mine is, because we don't want to plug the battery in and turn the robot on, especially with it in its current configuration. So there we go, battery's now in. And the next part of all of this is literally just getting these wires to sit down nicely. So for me, I normally try and get the battery up in the back here somewhere, but that means trying to work the wires around so that they will do that. I personally try and kind of like fold the power wires back and forth a little bit and jam the battery up in the back here. And then I try and get this balance lead out the back here as well, so that it's in a spot that I know exactly where that is. Then the receiver kind of sits in front of that, and we've got 2 things left. We've got the brushless motor and ESC. So I try and tuck the ESC down in this corner and then have the wires come out as a little slit here in the chassis. So that's where those wires need to go. So we're going to try and tuck all of this down in there, just like that. It's a little bit tight in there, but yeah, you can mess around with this a little bit. It's kind of a bit of personal preference. Just get the wires in any which way that they will actually sit down and play nice. Obviously, I've got something not quite in the right spot here. I think if I pull my receiver over, yeah, there we go. So my receiver needed to move this way to get everything in, and then once that's done, we now need to get the switch in place. Now the switch does seem like it's going to be a bit of a problem, but I'm going to lay my wires down a little bit and force the switch over into this corner. For the last version of this, I literally just glued the switch in place over here because my top plate did not cover this area, so you could easily get to the switch just like that. So that's kind of the wiring positions for a lot of these things. Like I said, it's going to be a bit up to you where you want things, and you can just kind of manipulate things back and forth as you need to get all of your wiring actually in. Now the next step, we're going to leave the motor till last here. The next step is the top plate here. So this top plate for me is actually off of, I think, headphone packaging. But like I said, you can use a juice bottle, whatever you like. Literally just cut it to this type of shape. Lay it down over top of your robot, and you're going to need 2 holes to stick screws through. So the way I find easiest to do this is lay it down, then with your screwdriver, kind of poke at it a little bit and just like spin your screwdriver, and you get a nice little notch on the plastic, which once again, I'm not sure how easy this will be to show up on camera, but you get a nice little notch in your plastic, and then with the sharper self-tapping screws, you can actually force those sharper self-tapping through this especially thin plastic, and that would just work. So that's how I put the holes in all of this. So this needs to sit on here, but as you can see, we've got these little tabs that fold in with Velcro. So we need to cut some of our Velcro. Yours will not have Velcro on it immediately. You're going to need to cut some little strips of Velcro and I usually put the hooks on this side and then the soft side on the inside of the robot. And then, yeah, the top cover goes on basically with the 2 screws here and the Velcro on either side, just to keep everything all nice and together. I think I do need to kind of rearrange my wiring in here. It's a little bit squishy, but like I said, you guys can have a bit of a play with that yourself. There's plenty of room over here, so if you can manipulate things so that like the receiver sits over here and the ESC sits over here, then you're going to be in a good stead. So there we go, just like that. And then we're going to work on the brushless motor. Now mine, I seem to have more cable on here than I did the last time I did this, so be a little bit aware that you might need to cut down your brushless wires a little bit to make this a little bit nicer, because at the moment mine are a little bit too long, but that's okay for now. So then we're going to sit the brushless motor in the end here. Now there's a little hole where the clips and things line up. And then we're going to try and spin it round until we can see all 4 of the screw holes coming out through the T-pieces in the back here. And we're going to take our tiny little screwdriver, Allen key, and bolt the motor down just like this. Now, you should be using Loctite on these. I'm not at the moment because I'm doing this rather quickly, and I'll probably take this apart and redo it again later before I fight it. But to make sure that your motor stays in place and does not fly off and break the entire robot, put a tiny drop of Loctite on the end of each of these little screws here, and that will keep the motor in place, at least for a single tournament. Every other tournament also, you really should be pulling all of your bolts out and re-Loctiting them in place, because Loctite doesn't last forever, especially when things get hot, and motors in combat robots will often get hot. So, there we go. Okay, so now that is in place, I would suggest doing all 4. Once again, I'm just doing this for speed, so I'm just showing you guys all of this. Once that's in place, you should tape down your extra motor wires. As I said, I have kind of overdone this with my wiring, and before fighting this, I'm actually going to go back and cut down these wires so that they're not quite this long, because extra wires is actually a really bad thing in a combat robot, and we really don't want that. But we're going to tape those wires down so that they can't ever make their way up into the weapon, because that is a very, very bad thing, and it is a great way to lose your weapon in a fight, is have your weapon wires sucked into your weapon itself, and that's going to just kill the robot, or kill the weapon at least. So then the final things we're going to do, we're going to push the weapon into place, just like this. So this guy's spinning, is supposed to spin this way around. Oh, there we go. We've got some hot glue caught up in things. But yeah, so we've got our weapon spinning this way around. Then we're going to need the nut for that. Here it is. We'll also pull the wheels in at the same time. So we're going to thread this guy on here the same way we did before. And when we get down to the bottom, we're going to sit the robot up, grab hold of the motor with our fingers, and then try and lock this nut down as tight as it will go. So using your pliers and holding onto the brushless motor with your fingers so that it doesn't slip, try and get this as tight as you possibly can. And once it's down there and locked in place, you should see that when the motor spins, the weapon spins, and everything kind of goes all together, just like this. And once that's in place, then we're going to get our hot glue back again. I'm going to, once again, add hot glue over top of the nut. That is to stop the nut from coming undone while you're spinning and hitting things with the weapon, just like that. Now, that does also make this whole section a little bit taller, but that is okay. Finally, well, almost finally, we're going to put on our wheels. Now, before you do this, you should super glue the rubber to the wheels themselves. And that's why I said at the start of this video to get the cheap super glue, because cheap super glue bonds rubber like these to plastic really, really well. Any name brand stuff doesn't like to stick to rubber, from what I've found, which is very odd, but that's just what I've seen in the past. And yeah, if you don't stick your rubber onto your wheels, they can come off during a fight, and that will mean they'll get caught in here and jammed up, and you won't be able to drive very well. So yeah, super glue your wheels on. These ones are already done. I can't move these rubbers off the wheel hubs. And the wheels themselves are cheap enough that if your rubber ends up completely disintegrating, just buy another pair and keep going. So yes, we're pretty close now. The last things to do are to put this cover on in here with a couple of screws and some Velcro, which I'll let you guys do on your own. And then finally, we have the wire, which we were going to use to drive upside down. So this actually might not be quite enough wire, because what I want to do is attach it to these two corners out here. So I might have to bend this a little bit differently, just like this. So we're going to bend it so that it reaches these two corners. Then with our pliers, we're going to bend it down a little bit on both of these sides, trying to be as even as possible, just like this. And then we're going to try and get this to be, this is going to be our contact pad for the actual front of the robot. So we're going to glue these in place just with hot glue. So if I pull this wiring out of the way a little bit, get the hot glue gun and dump a bit of hot glue in here. The only problem with hot gluing this stuff in place is that you need to be a little bit careful with it while the glue is drying or cooling down, because it's not going to stick and hold immediately. You kind of want it to cool in place. So we're just going to have to let that cool for half a second. Once that's more cool, we'll stretch this out and glue the other one in place. I have to wait for this one to cool down. Okay, so once they're both cool, like this, then we can shape this piece of wire, because we want it to be away from the weapon a little bit. And we also want it to have a smallish contact patch right above the weapon itself. So I kind of angled it up like this, as you can see there, and I've kind of pointed it out over the top of the weapon because this is where the weight is at this end of the robot. So this is where we want to be skidding along the ground. So if I jam this switch back in here, set this on the ground, it should sit on that piece of wire and nothing else, because that way it's going to drive a lot better and the wheels are going to be contacting the ground the whole time, which is what you want. You don't want either of these wheels to be lifted off the ground at any time. As you can see, this spinner sits a little bit high now, so it's possible that we can actually modify this a little bit, and literally just by tweaking our wire back down again, just like this, we can see that the spinner now sits a lot flatter, and that is actually going to work better. And as you can see, the wheels are still touching the ground because they still move as the whole robot moves. So that's good. That's what we wanted to see out of this. The only thing is, the closer down you get, the closer the spinner is to the wire hoop, which means the more danger you're in of your robot hitting itself. And you kind of don't want that. You want to avoid this if it's possible. So personally, I would leave that up quite a lot so that the spinner is clear of your underarm here, which is to literally just to keep you off the floor when you're upside down. But if you want to drive the whole robot upside down all the time, then you can push it down a little bit lower, but you do need to understand that you're running the risk of hitting your own robot chassis. And that's not going to be good for anybody, but it does mean that your horizontal spinner is lower to the ground when you're upside down. Okay, so now that thing is done and dusted, it's time to give this thing a quick test, and then that'll be the end of this video. Okay, so that didn't go all that well. I think there's a coil out in the brushless motor that I have running this weapon, and I don't actually have time to replace this weapon. So instead, I will show you some clips right now of Guestimate fighting with the actual PLA bar in the old yellow chassis version. So there you go. You can see that the thing does drive around, it does spin up, it does work. But as I said, this is definitely an impactor weapon, and because we're using screw heads for teeth, it's not going to be brilliant, but it will get you or get anybody through a first tournament. I would recommend, though, printing a couple of spares of the weapons just in case they do break, because a weapon-to-weapon hit with a heavy horizontal, you're probably going to break this weapon, especially if they're running a metal weapon. However, like I said, this is all about getting somebody into the arena for the first time. So the upgrades that can and probably should be made, replacing this weapon with a metal weapon. A lot of people who upgrade weapons or go for their first weapon have like a metal ruler or a section of a metal ruler with a hole drilled in it, but of course that would mean adding an extra tool to this build. So that's why it's an upgrade after the fact. If you can get yourself a drill or get your hands on a drill, you can replace this weapon with a metal weapon. You can also change out the motor that's in under here by leaving using the star-shaped carbon fiber drone arm. There is space in here for different weapon motors, so you can use a thinner, a lower down weapon that might actually have a larger diameter on it, so that can change where your weapon height sits, that type of thing. You can also go ahead and make your own custom wheels. These ones work really well, but silicon wheels do grip better than these wheels do. So you can follow the tutorial in the links below to make your own wheels, 3D print some hubs, make up a mold and do some silicon wheels. Once again, there's more time and effort and process. It's something that I would recommend you do, but it is something that you don't have to do to get into the arena the first time around. You can also, do some upgrades, like upgrade this top piece, whatever you like. There is a little bit of weight left over in this guy for some upgrades if you want to do them. And as I said, or as I should say, like I said, this is my attempt at doing a very easy beginner's spinner combat robot. If you think you can do a spinner, beginner's spinner in a different weight class with less tools, with less materials, with less cost, please go ahead and do that. But I implore you, put up a tutorial so that it is out there for the world to see, so that beginners have reference material that they can grab hold of and try and use. So yeah, like I said, if you think that you can do this better than me, by all means go ahead and do it and put that tutorial out there. Let other people know how you did something easier, better, cheaper than I did myself. Yeah, so there you go. Like I said, that is going to be it for this video. I hope you guys have enjoyed that one. I hope I see some of you out there with these robots out there. Like I said, there will be links to everything down below. All of the parts, files on Thingiverse, everything that I've used that's gone into this robot will be in the description. So be sure to check all of that out. And I will see you in the next video.